Hi, this is Mrs. Downey and this is Algebra 2. Today we are doing Chapter 6, Section 3, Binomial Radical Expressions. Our objective today is to add and subtract radical expressions. So for our bell work, I've asked the class, explain in your own words what like radicals are and give 3 examples. After you do that, I want you to add those 3 examples together, however you think they should be added. So if you don't know the rules or how to do it, give it your best shot. There's no right or wrong here. Everybody must put something, and we'll learn about this today, and we'll revisit this at the end of class. You may pause here. Okay, like radicals are radical expressions that have the same index and radicand. So, for example, I have the same index by having 3 as my index right here. So those are the same. And then if we look at the radicand, my radicand is 6x in this expression and 6x in this expression. So because my radical expressions have the same index and radicand, then they are like radicals. There are things that we can do with our like radicals. So here's how we can combine the like radicals using the distributive property. So if I have a like radical, like right here, square root of 2 plus 3 square root of 2. This is just like having a 1. If nothing's there, it's like having a 1 in front of it. Well, what we do is we're going to add the numbers and keep the radical sign with its radicand. So it becomes 1 plus 3 radical 2, which is 4 radical 2. Then radicals with variables, like radicals with variables, they have an example here, radical 5xy, and that's like if there's no coefficient, just put 1, plus 8 radical 5xy. That's the same as saying 1 plus 8 radical 5xy, which is 9 square root of 5xy. So this is like radicals when they have the same index and the same radicand. Then with the addition or subtraction, and you can work subtraction the same way, except for example in this one we're going to have a 1 minus 5, which is negative 4 cubic root of 7. Excuse me. So that is working with addition and subtraction of like radicals. Now you may want to go back, pause here, and revisit your original equation that you created with your bell work. So here's a property now that we can say, combining radical expressions with the sums and differences using our distributive property, we can add or subtract our like radicals. So that was just regrouping like I did a moment ago. So if I have this plus this, I can just say it is the same as a plus b times the root and radical, or the index and radical. And subtraction the same way. So combining radical expressions is different from just adding them. So the sum of any 2 real numbers is a real number. So you can add radical 2 and radical 3 to get the real number, radical 2 plus radical 3. However, it is not like adding radical 2 plus 3 equals radical 5. That is not the same. So keep this in mind. when you work. And actually, here's proof that they are not the same. So there's radical 2, radical 3, and there's radical 2 plus radical 3 is 3.146. And when they do a radical 5, see, it's a completely different number. So be careful. You can't just add the radicands together of square roots. Okay. So our first set of problems, we've got adding and subtracting radical expressions. What is the simplified form of each expression? So the first one, they give us 3 times the square root of 5x minus 2 times the square root of 5x. So they are both squares, index of 2, and the radicand is 5x. So they're like radicals. So all we have to do is the 3 minus 2. So 3 minus 2 times radical 5x. We're using the distributive property when we regroup those. And now we just simplify. The 3 minus 2 is just 1. And we don't write that 1, just like we don't write a positive sign in front of every positive number. We don't write the 1s in front of things. It's just the radical square root of 5x. Next, we've got 6x squared times the square root of 7 plus 4x times the square root of 5. So are these like radicals? That's the first thing you need to check. And in this case, I've got a radical 7, radical 5. These radicands are not the same, so we cannot combine these. There is nothing to combine. So on C, let's look at our index. We've got an index of 3 and an index of 5. Again, because our index are not the same, we cannot combine these. They're not like radicals. So now take a moment and work A, and we'll come back to this in a moment. Pause your video now. Okay, so let's look at these. On the first one, we don't have the same index. So for A, we've got a 3 and a square. So they're not the same. You cannot simplify this one. For the next one, they're both a square, and they both have the same radicand, so they're like radicals. So we can combine these. So we're going to do the 3x plus 4x times the square root of xy. And that comes out to 7x times the square root of xy. And then our last one here, let's look. We have same index, and they are like radicands, so they're like radicals. So all you have to do is 17 minus 15, which is 2, times the 5th root of 3x squared. So at this point, I would like for everyone to stop and work problems 2 and 3 on 6-3 in their workbook. Pause your video now. Hi, we're continuing lesson 6-3 with Algebra 2. This is problem 2. We're coming back from doing some workbook work, problems 2 and 3. So on problem 2, we've got a word problem about using radical expressions. In architecture, it says we've got a stained glass window design. The side of each small square is 5 inches. So each one of those is a square. It means that each side of those individual squares are 5 inches each. They want us to find the perimeter of the window to the nearest 1/10 of an inch. Well, the perimeter, nothing is perfectly on a side. They're all on the diagonals. So we need to know, if we have the length of the diagonal, we know that this is 2 of those, and this side is 3 of those diagonals. So if we have the length of a diagonal, we can figure this out. Well, it just so happens that we've got a formula for the length of a diagonal of a perfect square, and that is the length, or the side of a square, times radical 2. So our length of the side is 5, so it's 5 radical 2. So for this bottom piece, or actually they start with this long side. The long side here, we've got 3 of those. So it's going to be 3 times 5 radical 2, which comes out to 15 radical 2. And now we're going to have 2 of those, right? We're not there yet. So we've just got one side. Now let's get the other, the bottom side. And we've got 2 down here. So that's going to be 2 times 5 radical 2, which comes out to 10 radical 2. Now we'll do our perimeter formula. We know that perimeter is 2 times the length plus 2 times the width, because we're talking about perimeter going all the way around. So we're going to go from here to there, to there, to there. So what is this? It's 2 times the length, 2 of those, and 2 times the width. That's perimeter. How much fence do we need to put around the area? So now we need to substitute for our length, and we said our length was 3 times 5 radical 2, which was 15 radical 2. Oh, they put the formula in. 2 times 15 radical 2. There it is. And now 2 times the width. And we said the width was 10 radical 2. So there it is. Now we're going to continue to simplify. And we need to look. We've got a 15 radical 2 times 2. So that's going to be a 30 radical 2. And our next one is 2 times 10 radical 2, which brings us to 20 radical 2. Now we have like radicals. Okay, so we can add this to 30 plus 20 radical 2, which is 50 radical 2. So that's the perimeter. They ask us to use a calculator to approximate. When you punch that in, you get about 70.7. So the perimeter of the window is about 70.7 inches. So the guided here is to find the perimeter of a window if the side of each small square is 6 inches. So you may pause here and solve if you would like, or continue on with the homework. Okay, our homework is the practice K. Work right now, problem 4. Pause and come back when you're done. Okay, so I wanted to show you, in case if you got it, well, the diagonal, which I have to dig, is s times radical 2, s being the side of your square pane, and we say it's 6 here, so 6 radical 2, and we know on this, on the length, we have 3 of those, and on the width, we have 2 of those. So let's plug that in. The length is 3 times 6 radical 2. Width is 2 times 6 radical 2. And simplifying both of those, we have 18 radical 2 for the length and 12 radical 2 for the width. Now, plug them into your perimeter formula. When you do that, perimeter equals 2 times the length plus 2 times the width. And so you just plug in for length and width. And we get 2 times 18 radical 2 plus 2 times 12 radical 2, which comes out to 36 radical 2 plus 24 radical 2, which comes out to 60 radical 2. I didn't plug that in the calculator, but you're welcome to do that. For time's sake, I'm going to move on. Problem 3, simplifying before adding or subtracting. It says, what is the simplest form of an expression? Radical 12 plus radical 75 minus radical 3. Well, we can't just combine those because they're not like radicals. We have to have, they all are square roots. They all have an index of 2, but the radicands are all different. So there's nothing we can combine here. So what we need to do is put these in terms of like radicands if we can. So that means we have to start taking out things. These are square roots, so we need to get things in squares of 2 if possible. So 12 is what? 4 times 3, And we know that 4 is 2 squared, right? So there's that. Now what about 75? Can we use a square factor in that? Well, yes, 25 times 3, correct? And we know that 25 is just 5 squared. And subtraction of radical 3, not anything we can do with that. It just stays the same, just carry it down. Now let's continue on. So now you know we can separate these out. The radical 2 squared times radical 3, and then they just split this one up here. 5 squared radical 3, and then carrying down still the negative radical 3. And now we know that 2 squared, the square root of 2 squared is 2. So simplify that times radical 3 plus, and the square root of 5 squared is 5, radical 3 minus radical 3. So now we've got everything in like terms of square root of 3, square root of 3, square root of 3. So now we can just perform the math functions on that, and we get 2 plus 5 minus 1. Don't forget that this is like a 1. So 2 plus 5 is 7, minus 1 is 6, 6 radical 3. And that's our answer. So here's another one for you. If you'd like to work the got it, you have what is the simplest form of the expression? The cubed root of 250 plus the cubed root of 54 minus the cubed root of 16. So you know you're going to have to try to get things in terms of factors that are cubed. I'm going to pause here. And also in your workbook, turn to the 6-3 practice K and do problems 5 and 6. So pause now. Okay, and work in your workbooks numbers 5 and 7. And here's the answer to got it. So you want to get everything in terms of cubic factors. So here it goes. The 250 went down to 125, which is 5 cubed, which took the 5 out. So 5 cubic root of 2. And the 54 is 27 times 2. 27 is 3 cubed. 3 cubed, 2. And then 16 is 8 times 2. 8 is 2 cubed. We take out the 2. So everything came down to like radicals. So 5 plus 3 minus 2 becomes 6 times the cubic root of 2. And that was your got it. And I'm going to end this video here for the next video. Okay, continuing with Algebra 2, 6-3. We're on problem 4. Now we're multiplying binomial and radical expressions. What is the product of each radical expression? Well, I see a binomial times a binomial. So don't forget what we have to do. We have to FOIL, which is first, outside, inside, last. First is first term of each binomial. Multiply them together. So it's going to be a 4 times 5. And then outside is going to be like the first term and the last term, the outside terms. So 4 times 4, radical 2. So there we go. And inside are our 2 inside terms. So next we're going to go 2 radical 2 times 5, and there it is. And our last term is the last of each binomial, 2 radical 2 times 4 radical 2, right there. Okay, so once we get those down, then clean it up. So 4 times 5 is 20. This becomes 16 radical 2. This becomes 10 radical 2. And this becomes 16. Okay, now combine all your like terms. 16 plus 20 is 36. And then combine these radical 2's. 16 plus 10 is 26 radical 2. So there's your answer, 36 plus 26 radical 2. Our next problem is now with a minus sign. Binomials with minus signs. So again, we're just going to do the FOIL process, paying attention to our negative sign. So start by writing your equation, and let's start the FOIL process. Get yellow now. All right, so the first one, move this up. We're going to do the first, so 3 times 5. Outside, 3 times radical 7. Inside is negative radical 7 times 5. And then last is negative radical 7 times radical 7. So there it all is. And now clean it up. So we had 3 times 5 is 15. And then we've got this minus, it's going to be a 5 radical 7. So 3 minus 5 radical 7 is negative 2 radical 7. And then last, you've got minus those squared becomes radical 49, which is just 7. So it's a negative 7. Okay, so now combine your like terms. And you have 15 minus 7, which is 8, minus 2 radical 7. And that's our answer. It's that simple. Now I've got it, but I would like for you to work problems 8 and 9 in your workbook. And I'll come back with the answer for the got it. Pause this video now. Okay, so now I'm back, and you should have finished problems 8 and 9 in your workbook, which were very easy. And if you worked the got it, here it is, worked out. And the answer was 46 plus 16 radical 5. I want to state that conjugates are expressions. We worked on these in Algebra 1. It's like radical A plus radical B and radical A minus radical B. They only differ in the signs of the second terms. Everything else is the same except the signs in the middle. So when A and B are rational numbers, the product of two radical conjugates is a rational number. So let's look at how this works. So here we go, multiplying conjugates. What is the product of 5 minus radical 7 times 5 plus radical 7? So the first thing we're going to do is write our problem and then start our FOIL process. So we're going to have 5 times 5. First, outside is 5 times radical 7. Inside is 5 times negative radical 7, which is negative 5 radical 7. And then last, we're going to have a negative radical 7 times a positive radical 7, which comes out to a negative radical 7 squared. So now, when you simplify everything, you end up with 25 minus 7. I know some of my students are going to wonder, how did that happen? Well, you've got 5 times 5 is 25. And notice that you had 5 radical 7 minus 5 radical 7. Your middle two terms cancel each other out to 0. And then radical 7 squared is just 7. So you've got your minus 7. So 25 minus 7. Now, when you calculate that, 25 minus 7 is 18. So remember, we did these in Algebra 1. Okay, here's our got it. We've got 2 of them here. You're welcome to work these. And I would like for my students in their workbook to work number 11, 12, and 13 in their workbooks. So pause now. I wanted to point out that just like in Algebra 1, when you multiply conjugates, it's always going to come out to A squared minus B squared. So let's look at how that works here. My A is 5 and my B is radical 7. So 5 squared minus radical 7 squared. 5 squared is 25 minus radical 7 squared is just 7. 25 minus 7 is 18. Okay, so that should help your work go much quicker. So again, pause, do your work. Okay, so here we go. The first one we have here is my A is 6, my B is radical 12. So it's going to be 6 squared minus radical 12 squared, which becomes 36 minus 12, which is 24. And over here, A is 3, B is radical 8. So it's going to be 3 squared minus radical 8 squared. So it's going to be 9 minus 8, which is 1. So those were super easy. It shouldn't have taken you but 1 or 2 minutes to do all 3 problems. Okay, let's move on. Okay, so sometimes a denominator is a sum or a difference that involve radicals, and if the radical expressions are square roots, you can rationalize them by multiplying the numerator and denominator by the conjugate. So let's look at what that looks like. It says, how can you write the expression with a rationalized denominator? So there's your clue, as it tells you you're going to have a rationalized denominator. So we have 3 times radical 2 over radical 5 minus radical 2. So the first thing you need to do is write it, and let's look at what we have. So we're going to start off with what we have, and now let's multiply it by the conjugate of that denominator. So over here we had 5 minus radical 2, so the conjugate of that would be 5 plus radical 2, right? And that would get rid of all those square roots underneath on that denominator. So when we do that, we know that it's just going to be a squared minus b squared, okay? And then they're just distributing here, my 3 radical 2 times the top of my conjugate there. And then we get that distributed, and then radical 5 squared is 5 minus radical 2 squared is 2, so it gives us 5 minus 2, which is 3. And then they simplify our numerator, and it comes out to 3 times radical 10 plus 2. And notice that the 3's will cancel out here. And I end up with radical 10 plus 2. Okay, here's our got it's. Okay, and here is the answer, quickly scrolling down to the first got it. It's okay, so here was, I ran out of video. Here's the last got it, A, and here is the solution worked out. To our answer is equal to negative radical 21 minus radical 35. And the last problems that we're going to work with, problem 6, was numbers 15 and 16. And that's it. Turn it in at the end of the hour. This is a recap of all the problems we worked and what numbers in the workbook we worked with that problem. So problem 1 we did in the workbook, number 2 and 3. After problem 2 we did number 4 in the workbook. Problem 3 we did workbook 5 and 7. Problem 4 workbook 8 and 9. Problem 5 workbook 11, 12, 13. And problem 6 workbook number 15, 16, and turn it in at the end of the hour. If you didn't finish, turn it in anyway, unless the teacher instructs you otherwise. Thank you, and have a great day, and happy math. Work hard.